Okay, do excuse the mess, but this is going to be an update on that motor I showed, the Lidmotor microamp pulse motor that I've been working on. And as you can tell, it's not in sight. What we've got here is an original dancing flower, and you can see that this guy isn't moving whatsoever, and the distance there to there is about 1.5 foot, somewhere like that. This here is a 4-foot ruler, or 1.2 meters. And over here is the motor, and it's spinning away. And all that I'm using for power on it is exactly the same solar cell as is on the dancing flowers. And there it is, spinning away. So just to show that this guy does work, I'll put him nearer to the light. Just put the thing straight and he should start to kick in now. There we are. He's going to start to move in front of the light. But even so, I mean, normally they're supposed to be in sunlight or, you know, really good decent light on a windowsill, and so you don't get that much movement off these things even when they are nearer to the light. So this over here, being able to move like this, being able to spin, yeah, that made my day. There are a number of changes, and the next thing I'll do is to detail those on the circuit diagram. Right, so to explain this, and do please keep watching because I've done some really eye-opening experiments this morning with this. Anyway, what I'm basically doing now, if you have a look at the circuit, is instead of directly powering the original coil from the collector of the MPSA 18, in fact what we're doing is we're running through the coil there. And that's a 25 plus 25 turn 1-to-1 ratio isolation transformer is the idea on ferrite. So what we've got here now is that energy is picked up by the coil from one side, and that enables the rotor to spin. On the other two sides, as you can see with the two pairs of coils on the right hand side here and this one here, we're picking up the energy. And what's happening with those is one output goes directly out to the positive, the other output is rectified by the germanium diode from the negative there and goes back into this transformer. Now I'm not quite sure of the operating principle myself, but it certainly works well, and I'll show now how well. Alright, it's now the next morning, and you can see that you see a couple of shadows and stuff, but the sun is certainly not coming into this room. It's quite a dark room. In fact, there's only one main window at the front. Yet this thing is spinning around absolutely fine. We've just got the small solar cell again on the left hand side, but just with, I don't know, lowish average light in the morning in this room, no issues at all. There's a couple of things I'd like to show, and hey, sorry about the bad lighting, but if I give this the mildest of turns, just to start up like that, it will now carry on, and that's different to how it was before when I needed to give it quite the spin of the shaft. You might be able to tell now it's actually picked up some speed. So that's a good change. It will start from the merest of turns. Usual dancing toy type things. Not a single peep from any of them, no movement whatsoever, as would be expected when there's not decent light coming in. But the motor over here is running fine, and I've got the solar panel in about the same angle and everything as these guys have got, but that's running happily. And finally I thought, right, let's put some shade on that panel. So I put the three dancing toy type things in front, of course none of them moving. The panel behind, in the shade of them, the damn thing's still going. So in a Jeremy Clarkson voice, how is it doing it?